Welcome viewers in my third lecture on automated manufacturing system. In my last lectures, I have discussed 4 performance measure of an automated manufacturing system like MLT, machine utilization, like work in progress inventory and throughput. In this lecture, I will discuss another 4 performance measure of an automated manufacturing system. These are flexibility, quality, then capacity, performability. First, flexibility. The simplest definition of flexibility is variability, or you see, if I observe the market, today's market is changing very fast. That means, if this product is now functional in the market, this product may be obsolete within a very few time. That means, lifespan of the product is very uncertain. So, my manufacturing system too is to accommodate this flexibility, so that it can quickly change over from one product to another product. Any modern manufacturing systems say for, let me try to understand graphically what is the impact of flexibility in manufacturing systems. Say this is your flexibility or variability. Or variability. This is your productivity or quantity, or say quantity, Q quantity. If I consider a general purpose machine, say for like GPM, GPM stands for general purpose machine. As for example, center lathe, milling machine, if I observe this type of machine, I can see it can produce almost all type of products in center length, almost all type of product with some attachment or some special features, adding some special features to the machine. But if I increase this type of machine, flexibility, you see flexibility is highest, but at the same time productivity of this type of manufacturing system is very low. Another extreme point, another extreme machining system, if I consider, it is called SPM, special purpose machine. That means special, SPM stands for special purpose machine. As for example, screw cutting machine, screw producing machine, screw nail producing machine, As far as quantity is concerned or productivity is concerned, this type of machining system is should have the highest productivity. At the same time, its flexibility is very less. That means, in this type of machine I can produce only this type of component. If the something happen, if this type of the produce this nail, if this is no longer is suitable in the market, this type of machine becomes obsolete. So, in between what happens? In between this system what happens? Here in between this system what happens? Here I am sacrificing some flexibility and I am sacrificing some productivity, so that in the middle, so that some flexibility is there, at the same time some medium productivity is there. That means, I am compromising for the benefits of something, for the benefits of others. Any automated manufacturing system like flexible manufacturing system, computer integrated manufacturing system, any automated manufacturing systems comes under this category, where some flexibility and some productivity is compromised. So, it is basically I can call it, any automated manufacturing system is basically a mid volume, mid variety manufacturing systems. So, this relates to flexibility. It should be flexible, at the same time should have a standard productivity of the system. Next I come to next parameter, quality. Quality is defined in manufacturing, quality is defined conformance to the specification, conformance to the specification. But how do I quantify this quality? How do I quantification of quality? quantification of quality. Traditionally what's happened? Traditionally it was assumed that any deviation from the desired size, desired size, say upper lower limit, lower control limit, upper control limit. If a product lies within this zone, it is the quality of the product is good enough. This is a basically classical concept of quality. Classical concept of quality. Later on, Taguchi gave a newer concept of quality. He told that no, if any deviation from the desired size, it is definitely a loss of quality. It is definitely a loss of quality, whether it lies within the lower control limit or whether it is coming under upper control limit. Any deviation from this is called, Taguchi told this as it is a quadratic in nature, Taguchi a quadratic loss function. This is actually what is quality. Now, how do I quantify this quality? Quality of any manufactured product or any quality of any automated manufacturing systems is basically measured by two parameters. One is accuracy, another is precision, What is accuracy and what is precision? Whether a precision equipment is accurate, all precision equipment is accurate, or all accurate machine is precision, or accuracy and precision have no relation at all. Let us try to understand these things graphically, because these two terms frequently confusing in nature. Suppose say you have to throw 5 bullets. This is a inner hole. Somebody shoot 5 bullets here, something like that. This is your eye hole. Somebody throw 5 bullets here. Somebody throw 5 bullets here, right? Somebody throw bullets here, say. Actually, precision it represents basically repeatability. Or accuracy represents deviation from basic size. Say, in this case, as this is very all of this bullet is very closer to the basic size, this may be accurate, but at the same time as I consider the repeatability aspects, these are very far from these things. That means, this system is accurate, but not precision. This system, as it is very closer to the my desired size, at the same time distance from each other is less to compare to this. This my machining, this system is accurate at the same time precision. This system as I see, this is very closer to each other. This system is but very far from the my basic size, my desired size. It is not accurate, but precision. This is not accurate, not precision, and obviously this is more accurate and more precision than these, but and not accurate. Now, how do I quantify this? This can be quantified. This can be quantified by an example. Let us see. Let us see this. Suppose somebody have been asked to produce a 10 diameter, a shaft 10 diameter, 10 mm diameter shaft in a lathe machine. So, he has machine number 1 and machine number 2. So, in machine number 1, let us take some arbitrary data. Somebody have 10.1, 9.8, 9.9, say 10.2, say 5 shaft, let me give you 9.7. And in machine 2, where he has produced say 10.01, 10.3, 9.7, 9.8, 9.99. Say for example, just for example, how do I assess that this machine or this machine is more accurate than this machine or this machine, or more precision of this machine and that machine? By mere observing this data, I can't do that. I can't do that. So, what I have to do? I have to calculate first standard deviation. What does it mean? That means I will calculate some what is the standard deviation is equal to summation of if it is a basic size is 10, then 10 minus x I by n, I is equal to 1 to n. I can calculate this, and I can calculate these also by following same thing for this machine. If this then I can tell that obviously that tell as this deviation is more, then I can definitely tell this machining system is more accurate than this machining system, because if this is, and vice versa, if it is less than, then I can call it is accurate than this one. While calculating, this is quantification of accuracy of any manufacturing system. While calculating the how do I measure the precision of the manufacturing system? It is exactly the same things. I will measure the standard deviation from the mean of this, not for a very basic size. That means, here in this case for precision, in this case I can calculate sigma 1 is equal to I is equal to 1 to 10 mu minus x I whole square by n. Same thing here in this case I can calculate for precision this much, same formula, and just seeing this standard deviation I call if it is in this case, if it is sigma 1 is less than sigma 2, then I can calculate my M1 manufacturing system is more precision than my M2 manufacturing systems. So, these are the qualitative measures of any manufacturing systems. These two parts of performance indicator is fairly simple. Let us go to the fairly simple. Let us go to the very basic definition of this. Capacity is nothing but the term capacity or plant capacity is used to define the maximum possible output of the transformation process the plant is able to produce over some specified duration. That may be production capacity per week, and the next performance measure is performability. One factor that has a major influence on system performance is the unscheduled downtime of the equipment due to failure. That means, in the reverse way I can call it is a reliability of the systems. Traditionally, reliability and availability are measures that capture the percentage of downtime or repair time. Combined analysis of performance and reliability is done using the notation of performability. So, in these lectures I have covered 4 performance measures: flexibility, quality, capacity and performability. In the next lectures I will discuss about mechanization and automation. How do I quantify the automation of a manufacturing systems? Till then, goodbye.